I can tell you a Finnish joke, by the way. How do you know social Finn? Well, he looks at the other guy's feet and not his own. So yeah, that's awkward. That's the level that we're starting off here. So, my name is Ilkka Turunen, and I work for a company called Sonatype as the lead solutions architect of the European customer accounts. In my job, what I do every single day is I interact with companies, predominantly larger enterprises, but also smaller software houses, to figure out something we call the software supply chain problem. Probably, how many of you here have heard that term? A few of you. That's great. You guys are the advanced crowd. Truth is, most people have probably heard the tool that I end up using every single day, which is something called the Nexus repo. Most of you seem to be nodding there. So in my daily job, what I do is I interact with companies to help them figure out how they deal with open source artifacts and how they move libraries into their development environments and gain the speed and efficiency benefits that Devops talks about within its constraints. But one of the more interesting discoveries recently that I've been working with for over the last 2 years is actually how much I end up actually doing security-related work and not development work. My background is in software development. I'm by no means a security guy. In fact, I'm the last person you should ask any proper security advice from, other than strong opinions and some lacony, snide comments under my breath. But throughout my career, I've worked with the private clouds, the public clouds. I started off with OpenStack when it was in the alpha, and then Bexar, and then Cactus release. Did a couple of larger projects, data center projects in Finland around that. And then I got tired of Finland because it's so cold, so I moved to a southern tropical island, also known as England, and I started working with public clouds. And I worked with enterprises in CI/CD projects, trying to figure out this continuous delivery and continuous integration piece. And time again, I ran into the topic of security. Let's face it, today in our industry, hackers are everywhere. This is every single day you can open the news and there's Russian hackers, there's ransomware attacks, there's someone's website that's being hunted. If you listen to the industry gossip, there's a lot of talk about new types of legislation. And there are plenty of great case examples of hacking recently kind of hitting the mainstream news. HipChat had a open hole where hackers could access user accounts. So HipChat had to send an email out to everybody to say reset your password. Interestingly, about a year ago in the US in November, there was a hospital that got shut down because someone managed to find a way into their patient information system and install a ransomware piece of software. Interesting. A couple of years back, this was pretty famous. There was a famous article on Wired about hackers remotely actually disabling a Jeep as a journalist was driving it. The hackers actually used the Bluetooth interface that you put your phone in and just exploited the whole thing through there. And actually, in that video, if you haven't seen it, it's a great watch. The guy is driving down a highway, and the hackers say, "Oh, we're going to kill your engine now," and he's got a big truck behind him. It's interesting, right? Ironically, in San Francisco, there was a ransomware attack last year as well, where their transport system, the municipal ticketing system, actually got owned by ransomware as well. So one day, when you tried to get some tickets, it would say, "Pay me 100 Bitcoin." Cost of transport in London is high, but San Francisco is off the charts. And finally, of course, we all know this recent wave of ransomware attacks that's been hitting different public institutions. In the UK, it hit the NHS, and right now, this week, there's a new wave going through the rounds that are all actually based on the Eternal Blue exploitation suit. So there is clearly an awareness of cybersecurity. In fact, this is the first year. I've been talking about DevSecOps for a couple of years now. This is really the first year that the industry, to me, feels like has taken a notice. And it is very, very much thanks to this public view. The truth is, the discourse of cybersecurity is pretty much at this level. Can anyone actually identify what the background image there is? Well, I'll tell you. It comes from a news article, breaking news post that tried to talk about hackers in the DNC case. And in fact, it's a screen capture from Fallout 3, the terminal hacking program, because it looks techy enough, so it's a good background image, right? Now, that's the level as an industry that we're really talking about security. You know, this is something that we've been saying for almost 7 years now, 6 years and counting. You know, Mark Anderson said software is eating the world. And, you know, to many of the enterprises that I work with, when I start interacting with them, that's the kind of perception that most of the companies have. You know, we're going to be eaten by software. You know, software is going to be driving our business, and we're going to have some risk that we're going to have to, at a later point, manage one way or the other. So let's perhaps do something or perhaps not. The truth to me is software has already eaten the world. That was 6 years ago. It has eaten it and spewed it out. I mean, we all know that every business on earth today is a software business. There's just no doubt about it. Every car you see running down the road over there, and I'm not talking about the Teslas, I'm talking about the regular cars of everyday people, have more lines of code in them than your iPhone does. Like, in total. That's how dependent on software we have become. In fact, software is now very, very, very close to human life. You know, there was a famous case of an insulin pump with a Bluetooth interface that other sets of hackers got to exploit, and they managed to find a way to empty the insulin cartridge on command. That's getting to be quite scary. Software is moving into parts of our lives that it has never been before. And that puts on a completely new pressure on how we do software security. You know, we've spent a lot of time talking about how DevOps influences the speed of development, and how, you know, for the last 7 years or so, we've been talking about move fast, break things, apologize later. And those have been very, very great things for the industry. You know, in a world where if your competitive differentiator is software, and the only way to get ahead of your competitors is by the means of software, the only way we can really work with it is, you know, delivering faster software. So typically, in an enterprise, I notice that this is actually borrowed from a colleague of mine, Josh Corman, that developers are incentivized on 3 scales. First of all, deliver the software on time. You know, that's the number one be-all and end-all. You know, that was what my bosses always told me. It doesn't really matter. That feature, you know, move faster, deliver in smaller increments. Second thing is deliver it on budget. You know, don't, you know, no software project ever hits budget. I've never seen one, but you know, that's kind of the pressure. And quality and risk, you know, acceptability of quality and risk usually comes in as the third stepchild of the entire process. That usually is the least of everyone's considerations. I'm sure we've all been at that point where, you know, a penetration test has hit the desk. It's a wad of paper this thick, and, you know, we have to do something about it. Eventually, someone sighs a deep breath and says, let's just get on with it. You know, we'll fix things later. We're going to go ahead and, you know, go ahead and ship this anyway, and we'll sign off the risk. And that, unfortunately, is pretty much the state of where we are at now. In fact, my company conducts a survey every single year. It's called the State of DevOps, State of DevSecOps, and also something called the State of the Software Supply Chain. And one of the more interesting and kind of not surprising findings is that in a typical enterprise, there's 100 developers to 1 security individual. So if you think about it, security is now in the limelight. And what can one guy do against a centurion? You know, even the film 300 had 300 people. What is one person going to be able to do against the tides that are the developers that have been told for years and years and years to move faster and break things and disregard the rules if it means getting more business and if it means getting things out there? But the truth is, not very, very much. We spoke about that, crossing that bridge and getting different teams together, and I really like that analogy because this is one of my standard slides. And typically, where security fits into this picture is that they're the troll under the bridge. So, you know, for a long time, development is hunky-dory. We're going to ship this fast. We're going to do it the best thing we can. And just as you're about to ship it out, there's a guy under the bridge that jumps out and says, "Well, no, wait a minute. now we got to stop this whole thing because I got to make sure that you built the right thing, and I got to make sure that, you know, we're not going to get hacked or whatever because of the security implications of this thing. It's quite natural if you really think about it. You know, security people today are generally incentivized by controlling damage. If you think about it, you know, one person cannot really do nothing else but be a damage control individual. If something goes wrong, it's the SWAT team that you send over to say, please make sure that that fire doesn't keep burning, because otherwise, you know, the implications are severe. And the rest of the activities that we typically associate with what we would really need to be doing, just there is no bandwidth. You know, big part of the theory of constraints is that you can only do so much in the end, and in order to get more throughput, you have to decrease the batch sizes. But if your only time is spent on controlling damage and putting out fires, you're naturally going to be relegated into a position where the only activity you can do is this kind of blocking activity. So that obviously doesn't work. You know, one big inspiration to the theory of constraints is a book by Deming called Out of the Crisis that he published in 1982. Deming is the guy that was behind lean manufacturing, and, you know, a lot of this stuff is behind, you know, the Phoenix projects and the DevSecOps, DevOps handbooks, etc. But one of the most relevant quotes that he said is, you cannot inspect quality into a product. He worked with auto manufacturing. He kind of quickly realized that when you ship out a car, it's too late to try and see if it's secure when it's out the line. You know, it's kind of a silly situation. You spend, you know, a day and putting tens of thousands of parts, putting a car together, and then some guy comes in and kicks the tires and sees if the nuts and bolts are fixed enough. You know, that probably is not going to end up in a secure car, because it's not a very scalable way of processing this. What Deming instead proposed is there needs to be a better understanding of quality earlier in the manufacturing pipeline. It's too late by the time the car has rolled out, because you're going to be swamped with VIP that you cannot take care of. So, what are the typical aspects of security? What do we typically do in this sort of environment then? Well, there are 4 domains, classical domains of security. It starts off with building defensible infrastructure, you know, building things that you can defend, you can rely on, making sure that you know, it's safe and secure. Second layer is operational excellence, getting really good at what we do, making sure that we understand, you know, we practice together, we become very, very good at the delivery part of the things. Third part is situational awareness. This is, you know, using your metrics to your advantage. You know, we spoke about monitoring today, and that's a key part of it as well. And at the very, very top, countermeasures are the things that you actively engage in order to stop, you know, the fire burning, and in order for you to be able to act on an incident when it happens. So this is the idealized version. This is where the most effect happens. The most effect is had at building defensible infrastructure. The analogy is quite simple. You know, let's assume the zombie apocalypse happens and you need to build a shelter, and you got infinite time. You know that it's going to happen later. Would you build a shed, which technically is a shelter, it's got 4 walls and a ceiling, or would you build a castle? Well, where would you rather be? Of course, you're going to be in the castle with the moats and the arrow holes and, you know, whatever you're going to do to protect yourself against the zombies. Yet, as an industry, especially in the enterprise, security is almost inversely skewed on the opposite end of the spectrum. We spend a huge amount of time as enterprises building firewalls that can restrict our activities, building restrictions that stop our flowing of work. You know, one of the most interesting things that I find about the effective DevOps is that it talks about making things meaningful for individuals. And that's precisely what's lost in the security activities at the moment. It's not meaningful to curtail every single movement and firewall every single application. I've even been to a company where every single website went through an antivirus scanner and took about 3 minutes to actually produce. I've seen companies where developers are completely offline because their security team doesn't trust them to do the right thing in the first place. So, and a huge amount of money and investment goes into the countermeasures bit, and increasingly, from a security point of view, not that much has gone into manufacturing. So, how do we manufacture better software then? How do we build better software? How do we build defensible infrastructure? Well, I find it interesting to actually go back to the basics, and the truth is, the basics are different from what I learned when I started learning programming. Most modern enterprise applications, according to the State of the Software Supply Chain survey, aren't built from scratch. Most of an enterprise application, about 80 to 90% of it, is actually comprised of third-party components, libraries, Docker files, frameworks, utility functions, leftpad, if someone had that luck. Loads of these convenience functions that help us do our things better. And again, it's quite natural that such things would happen, because hey, if we need to deliver software faster, we're going to increasingly rely on making sure that we're not reinventing the wheel. Instead, what we do is we assemble the piece of the application from these ready-made bits, and then we decide to fill in the blanks with our business value. Right? That's the typical software engineer today. They're more like a city architect rather than an individual house builder. We can see this at Sonatype because one of the things that we're behind for the community is we operate something called the Maven Central repository. It's the back end of the world's most used build tool, Maven, which is where most Java build tools got interacted, and it's got about 2 million uniquely indexed components today. Well, when we charted out the download rates, we've seen that year over year over year, the download rates of these libraries has increased. In fact, that chart only goes up to 2015. In 2016, it was 52 billion, and in 2017, I think we've already surpassed that whole number. So we're seeing about a 50% increase in consummation of open source artifacts year over year over year. It seems like the trend is just going to be moving forward. It's not only Maven that has this. NPM constantly, npmjs.org constantly sets download records. They got 50 billion, which is a staggeringly large number. And PyPy also recently hit 4.4 billion requests on the ecosystem as well. So the trend increasingly is we're increasingly relying on open source. That number, that ratio of 80 to 90%, if anything, is going to be increasing. Truth is, it's becoming a bit of a hygiene problem. When we surveyed about 1,300 different companies, we found out that 1 in 5 had some sort of security-related incident based on these open source components. They could track down a breach to a fault, not in their own logic, but in the open source component logics. And it actually kind of makes sense, right? If I was an attacker, would I try and figure out what you guys are thinking, or would I just find the 100 most popular frameworks and libraries and just run a Metasploit suite on them and see what sticks, right? Pretty easy equation. Well, the typical Java application has about 106 components, and 24 of those has some sort of known and documented security vulnerability. We're not talking about security vulnerabilities that are going to be discovered tomorrow, but the average enterprise application that we surveyed, there was about 25,000 of them. 24 of them had a known and documented security vulnerability, something that has a website, that has a piece of information about what that actually means, and not a lot of information about how that works. So if we think about a typical CI and CD pipeline, how do people try and control against these sorts of risks? How are we trying to increase quality? Well, a typical CI/CD pipeline is relatively simple. Developers get some source, they get some dependencies, they commit, that triggers a build goes in, we deploy into an environment, never have targeted builds, Dave Farley is happy, CI/CD, good days, right? Well, typically in an enterprise, you'll see 2 points of control. Either at the very beginning of this pipeline, these disconnected environments or some sort of approvals. You actually probably do it yourself. Before you download a library, you probably go to the website and try and figure out, is this good or bad? But how much time do you actually spend on it, really to do a deep analysis? When I was a developer, half an hour was a stretch. And the typical other part is the penetration test. It's the when we're just about to release, we're going to be pushing this into production, and we're going to see if this sticks, right? So these activities actually are massive time sinks. So in the theory of constraints, we also talk about lead time, the time it takes from an activity to complete completely. And truth is, these security activities are massive sinks of lead time. There's a lot of waiting for someone else to do an analysis and someone else to do implication vulnerability, impact vulnerability. And again, that penetration test goes back to the developers, and then we kind of scramble on the results of it and try and get better at it. Also, when we looked at vulnerability densities in final applications, we actually find that the density increases from Maven Central to the final manufactured applications by 0.5%. What this means to me is whatever we're doing today isn't actually working. In fact, it's making the thing worse. We're putting more and more documented vulnerabilities in. And that reason, and there's another research paper that actually came out this year from the Northeastern University that scraped the internet and found out that most handlebar inclusions on public websites had a known documented vulnerability. 40% of both jQuery and Angular vulnerabilities also had there. There's a horrible security vulnerability in Commons collections, and over 80% of the vulnerabilities there are vulnerable. And the reason for this is that, it's a very, very complex problem to solve. So DevSecOps is the answer for this issue. DevSecOps is a new movement, and that's why I wanted to bring in front of you today. I'll share with you a reference architecture based on my CI/CD pipeline. But DevSecOps is an attempt at changing the way we think about security. DevSecOps has a manifesto, just like Agile had a manifesto. But instead of saying security should be doing this or should be doing that, it advocates that we should be leaning in over always saying no. We should not be relegating security into a role where security goes in and says, please stop working. Instead, security should be just, I really like the tribe model, by the way, because I think security is a great way of, a great tribe to have as a part of your bigger DevOps pipeline. Security needs to be a part of everyday delivery. In fact, security, to me, needs to be a part of testing. Security needs to be embedded in the exact same testing suites that you run through every single day. You know, I call it the onion model testing. You have several different layers of tests that developers live and die by. So what we really want to do is make sure that automation that we already have serves to feed us into there. Now, there are plenty of tools that help you to do this, but the key message here is you need to find tools that fit early on in the pipeline, tools that help you give early indications to developers from day one of what they're doing, not from a, does this test pass and does it do functionally what I need, but for example, does this library have a known and documented security vulnerability? Because the truth is, you know, most of the exploits are things that we could be solving with basic hygiene, but yet most companies really aren't doing that. And there's a great GitHub repo called Awesome DevSecOps. I implore everyone to go and check it out. It's a great collection of all of the different utilities that various different companies have been using in order to implement testing throughout the places. For example, there's great tools from a community called OWASP, which helps us deliver these things better, and there's a great set of utilities from vendors and others that, for example, Metasploit is a great piece of kit. Finally, I love the statement that tooling doesn't actually mean that tooling isn't DevOps. Tooling is a facilitator of culture, but really it doesn't take away the need that you have to actually actively have a security team that actively tries to attack your own applications. You know, a big part of the kind of findings in Phoenix project, for example, was that they realized that they need to practice deployments in order to get better at deploying. The same thing stands for security. You need to actively practice being hacked by good people, by red team people, by your security people, so that you can actively become better at responding to those hacks. The truth is, if you look at all of these incidents that we've had so far, that is not the case. So there are some legislations. I'm going to leave you with a couple of tips that you can do today. First of all, give developers feedback as early as is possible. Here's an example of a tool that shows you, all the versions of your library that has known security issues. Design an approach that works with them, not against them. Developers have a series of tools that already they're using in order to figure out should they go forward or not. fail a build if it isn't compliant with your security testing. Make sure that you have some sort of security suite or at least some sort of basic hygiene check for these known vulnerabilities before you move forward. And finally, know what you run. That was a great discussion by the previous speakers. Have an understanding of what applications you're running in what environments. Collect reports. You already do that. You have the logs. Create a dashboard that tells you which applications run where. Have an understanding of what packages you install. And finally, what libraries you're using. That's pretty much it. The horn has got on. There's plenty of other things.
You need to get off stage.
No. But my message here is exactly that. Make sure that you figure out basic testing, and finally, get involved, because this is a field that's shaping up, and this is a field that wants to have input from all practices. Thanks very much, everybody. I really enjoyed it.
Thank you, Ilkka. I think this is personally, I think this is a great idea to suggest as an open space later, so that if people want to talk more about security and DevOps, which is clearly a thing that's missing, it's a great opportunity to do that. Here's a gift for you.
Oh, lovely.
We're going to leave the questions for now because we're running a little bit behind. But thank you again to Ilkka. It was a great talk, I think.